Hello, what's going on YouTube? I'm back with another video. Before we begin our RISC-v hardware multiplication, shout out to the sponsor, Raid Shadow Legends. If you don't know what Raid Shadow Legends is yet, that's unfortunate, but I really recommend you download it. So let's begin. So let's begin, okay? To begin, we're going to first we're going to have a table. I already pre-wrote it out so I would save time, but you're going to have a table that looks like this, okay? And we're going to multiply 4 by 3, and that's 4 times 3, so we know 4 times 3 is equal to 12, so we know our result should be 12, okay? But to begin, we're going to take 4 and we're going to turn it into binary. And this is, in fact, the multiplicand. So this goes here. So we're simply just going to write that out. 1, 2, 3, 4. And we have 8 bits here, okay? So 8 bits, and we have to make 4 with it. So it's going to be 1, 0, 0, because this is 1, that's 2, that's 4. Great, 2 to the power of 2 is 4. And why I'm saying that is because this is in this place, and 2 to the power of 2 is 4, and this is 2 to the power of 1, which we don't have, so it should be 0, and then that's 2 to the power of 0, which is just 1. Okay, so that is that. Now we're the multiplier, which is 3, so we're just going to bring that over here. Okay, and 3, this gets assigned 4 bits. So we're going to go 1, 2, 3. Or like, that's 4 bits, but 0, 0, 1, 1 is 3 in binary. Okay, and to begin, the product register starts at 0. Okay, so how it works in the hardware is we're going to have our first iteration. And in our first iteration, we're going to begin with part 1. And what this says is that essentially we're just copying the multiplicand into the product. Why? Because when you multiply something in regular math, or regular arithmetic I should say, you're just taking the multiplicand and taking the sum. That meant x number of times, and our x in this case is 3. So if we take 4 plus 4 plus 4, this is equal to 12, and x equals 3. Okay, so you're just taking that and you're adding it up 4 times. And so because of that, we're going to have 1 4 initially, or we're copying the multiplicand into the product. So it's going to be 0, 0, 0, 0, 0, 0, 1, 0, 0. Now, because we did that, we're just going to simply move the multiplicand down. Fortunately, I have a power of technology in my favor, so I'm not going to rewrite it. We're just going to go like that. And of course, it stays the same. We haven't really done anything yet. We've only went through one step. So basically, copy multiplicand to product. Great. So that is the first step of the first iteration. So I should write it like this. The next step, we have to shift left the multiplicand. So we're going to take this and we're simply going to shift it left. So when we shift it left, we're essentially multiplying it by 2. So it's going to be like this, and 1, 0, 0, 0. So that step is done. And the product stays the same. So it's just going to be 4. Okay, so this was shift multiplicand left. Now the next step, it's shifting the multiplier right, which is dividing by 2. So we're just going to have 0, 0, 1. 1 being the remainder. Shift multiplier right. Okay, and these values will stay the same, so it's going to be 0, 0, 0, 1, 0, 0, 0, and our product also stays the same. So that is there you go. That's the next step. So after that, we're going on into our second iteration. The second iteration, well, what happens? We're essentially going to check this first bit here. We're going to check if it's a 0 or if it's a 1. If it's a 1, we're going to sum together the multiplicand and product. I would like to repeat, we're going to sum the binary sum, if you will, the binary sum of the multiplicand and the product, and we are going to place that into the product area. So we're going to take the sum of this number right here, which is the multiplicand, and the sum of the product. So I'm just going to write it here so we can understand what's happening. 0, 0 is 0, 0, 0 is 0, 0, 1 is 1, 1, 0 is 1, and then the rest is 0, 0, 0, 0. So I'm just going to copy that here before I erase it. So it's going to be 0, 0, 1, 1, 0, 0, 0, 0. Okay. Now, just for our reference here, I'm going to zoom in and write a quick note. We're going to go write check. What is this? The least significant bit of multiplier. If 1, take sum. If 0, don't care. Okay, so that is what happens in the first step of our second iteration. Okay, and we're just going to leave this as is. None of these values will be changed yet. Okay, so now we are going to essentially take these two steps and repeat them. Okay, so we're going to shift multiplicand left. So that's going to be 0, 0, 0, 1, 0, 0, 0, 0. This one's staying the same, 0, 0, 1, and this one also staying the same, 0, 0, 0, 0, 1, 1, 0, 0. Okay. Now we're shifting right, shift multiplier. Please don't judge the spelling or the handwriting. So that's going to be 0, 0, 0, 0. And then these values again stay the same. We are not using them at the moment. All right, great. That concludes our second iteration. Now, our third iteration, we're checking again the LSB. Okay, so say it with me. So it's a 0, so we don't care, or essentially we're just not taking the sum. So if you guys want to remember my rhyme, that's cool. If not, it's okay. You'll probably have your own way of remembering it, but my rhyme is check the LSB of the multiplier. If 1, take the sum. If 1, take the sum. If 1, take the sum. If 0, don't care. Okay, so anyway, since after we check that, well, these values are 0. Which value is 0? That value is 0. That's the LSB that we're checking. Okay, and these, so we're not taking the sum, so we're not doing anything to the multiplicand, and we're definitely not rewriting or writing over the product. Okay, so then we go shift multiplicand left. So this stays the same. This goes left. And again, this stays the same. Okay, then we're shifting right. And again, it's going to stay the same. So yeah, it's basically going to stay the same for the rest of this time because we have no more ones. I would like to emphasize that the hardware would have to go through one more iteration. Why is there 4 iterations? Well, that's a good question. There is 4 iterations because there is 4 bits assigned to the multiplier. Now, if we were using a number such that it required more bits, then we would have to have more iterations. So, for example, let's say we had 4 again, and we're going to multiply, this is base 10 by the way, and we're going to multiply that, let's think here, we're going to multiply that by 17, okay, 10. So 17 in binary is 16, 0, 0, 0, 1, and that's 5 bits. Don't believe me? Okay, that's no problem. So we have 2 to the power of 0, which is 1. Then we have 0, which is 2 to the power of 1, 0, which is 2 to the power of 2, which is technically 4, but we don't need that. This is 8, but it's also a 0. And then this is 2 to the power of 4, which is 16. So this is 2 to the power of 3, so that's 2 to the power of 4, and that's 16. 16 plus 1 is equal to 17, not 13. Okay? And so in this case, we would have 5, that's a terrible 5. That's also pretty bad. 5 iterations. So to conclude, this value right here is the answer, and we're going to go ahead and check that. So we're just going to convert this back to decimal. So 2 to the power of 0 times 0 is 0. 2 to the power of 1 times 0 is 0. 2 to the power of 2 is 4 times 1 is 4. And then we have 2 to the power of 3 times 1, which is 8. 8 plus 4 is equal to 12. Hallelujah. We'll give ourselves a little smiley face. And essentially that is the hardware multiplication. Let me know in the comments or on Discord if you want me to go over how it actually flows through a hardware flow diagram. Anyway.